In question 1, we start by finding dy dx for y is 3x minus 2 to the power of 6. So we get the power down, so that's a 6. We deduct 1 from the power, so 3x minus 2 to the power of 5, times the derivative of the bracket, which is 3. And of course, this simplifies to 18 brackets 3x minus 2 raised to the power of 5. Now in part B, we need to find the equation of the normal to C at the point P with coordinates a third, 1. So we will start by evaluating dy dx at x is a third. So this means that we have 18 times 3 times a third minus 2 raised to the power of 5. And this gives an answer of negative 18. We are looking for the normal, so the gradient of the normal will be 1 over 18. And therefore, to find the equation of the normal, I'll be using y minus y1 is mx minus x1. I'm substituting here y minus 1 is 1 over 18 brackets x minus a third. I still need to get my answer in the form of ax plus by plus c is 0 with a, b, and c being integers. So I will start by cross multiplying to get 18y minus 18 is x minus a third. And to get rid of the denominator of 3, I will multiply everything by 3. So 54y minus 54 is 3x minus 1. The only thing that remains is to collect everything on one side. So 54y minus 3x minus 53 is equal to 0. In 2, we're given two functions f and g, and we need to start off by finding the value of f of g of 5. So it's a composite function here. So f of g of 5 means I first need to evaluate the g of 5. So g of 5 is 2 times 5 minus 7. So this leads to f of 3. And I substitute 3 into f. So 5 minus 3 over 3 times 3 plus 2, which gives an answer of 2 over 11. In B, we need to find the inverse of f. So we start by writing y is 5 minus x over 3x plus 2. We will then interchange x and y, leading to x is 5 minus y over 3y plus 2. And then the objective is to make y the subject. So I cross multiply 3xy plus 2x is 5 minus y, leading to 3xy plus y is 5 minus 2x. I have a common factor of y on the left hand side. So y brackets 3x plus 1 is 5 minus 2x, leading to y is 5 minus 2x over 3x plus 1. So the inverse of f inverse of x, is equal to 5 minus 2x over 3x plus 1. However, this is not the end of the story. We still need to find the domain of f inverse. And we start by noting that the domain of f inverse is the range of f. So I will actually sketch f of x and identify the range of f in order to get the domain of f inverse. Now this is the expression for f of x. So to start sketching, I will find the cuts on the axis. So when x is 0, y is 5 over 2. When y is 0, 5 minus x is 0. So x is 5. Let's go for the asymptotes now. We know that we have a problem when the denominator is 0. So when 3x plus 2 is 0, so at x is minus 2 over 3. For the horizontal asymptote, we consider y as x tends to infinity. So as x tends to infinity, the 5 and the 2 are insignificant, and therefore y tends to minus x over 3x, which simplifies to minus a third. So that's the equation of the horizontal asymptote, and therefore I now have enough information to sketch f of x. So there it is. We've got the horizontal asymptote at y is minus a third, the vertical asymptote at x is minus 2 over 3, the cuts on the y in the x-axis. We see that the range of f is all values of y apart from y is minus a third, because if you look on the y-axis, all the values are attainable apart from minus a third, and therefore the domain of f inverse is everything but minus a third. In part C, we're asked to solve f of 1 over a is g of a plus 3. So f of 1 over a is 5 minus 1 over a over 3 over a plus 2. And we set this equal to 2 times a plus 3 minus 7. So I have to get rid of the fractions within the fraction on the left-hand side. And for this to happen, I'll multiply everything by a on the left-hand side. So this leads to 5a minus 1 over 3 plus 2a, which is equal to 2a plus 6 minus 7. So 5a minus 1 over 3 plus 2a is equal to 2a minus 1. I will now cross multiply to get 5a minus 1 is 2a minus 1 times 3 plus 2a. So I will expand the right hand side to get 5a minus 1 is 6a plus 4a squared minus 3 minus 2a, which leads to 5a minus 1 is 4a squared plus 4a minus 3. I will collect everything on the right hand side, leading to 0 is 4a squared minus a minus 2. And then I will use the quadratic formula to determine the values of a. So a is minus negative 1 plus minus the square root of minus 1 squared minus 4 times negative 2 all square rooted over 2 times 4. And this gives answers for a of 1 plus minus the root of 33 and all of it over 8. In 3a, we have to find this indefinite integral here, which involves k, which is a positive constant. So I will actually start by noting that the derivative of the denominator is 6x. So I will take the 9 out. I'm left with x over 3x squared plus k within the integral, and I just say that if I had 6x in the numerator, that would be the derivative of the denominator, and to undo the effect of multiplying by 6, I will also divide by 6. So this leads to the outside simplifying to 3 over 2, and the inside being ln of 3x squared plus k absolute value plus c. It's an indefinite integral, so that's why we need the plus c. In b, given that this integral is ln 8 integrated from 2 to 5, we need to find the value of k. So in other words, we have been told that the answer we found in part A, 3 over 2 ln of 3x squared plus k from 2 to 5 is equal to ln 8, and we need to determine the value of k. So I will start by substituting the upper and the lower limits. The 3 over 2 is outside, and I've got ln of 3 times 5 squared plus k minus ln of 3 times 2 squared plus k, and this is equal to ln of 8. So this leads to 3 over 2 ln of 75 plus k minus ln of 12 plus k is equal to ln 8. Now I can combine the two ln's to give me 3 over 2 ln of 75 plus k over 12 plus k is equal to ln of 8. And now I can cross multiply to get that ln of 75 plus k over 12 plus k is equal to 2/3 ln 8, which can be written as ln 8 to the 2 over 3, which leads to ln of 75 plus k over 12 plus k is equal to ln 4. Now that I've got exactly one ln on either side of the equal sign, this means I can get rid of the ln's. So 75 plus k over 12 plus k is equal to 4. And I can now cross multiply to get that 75 plus k is equal to 48 plus 4k. And therefore 75 minus 48 is 4k minus k, which leads to 27 is 3k, and therefore k is 9. In 4, we're given the graph of log n base 10 against t. We are told that we pass through these 2 points, and we need to start off by finding the equation for this line. So I will actually start by finding the gradient, which is y2 minus y1 over x2 minus x1. So it's going to be 3.85 minus 3.08 over 5 minus 0. This gives an answer of 0.154. We can see that the y-intercept, the cut on the y-axis, is 3.08. And therefore we have that log of n base 10 is equal to 3.08 plus 0.154 t. In b, we have the model n is ab to the power of t, and we need to find the value of a and the value of b, giving our answers to 3 significant figures. So I will actually start by writing the model n is ab to the power of t, and then I will take log base 10 of both sides. So log of n is log of ab to the power of t. Now the right hand side can be written as log a plus log of b to the power of t, which means that we have log a base 10 plus t log b base 10, and this is the expression for log n base 10. So I'm just going to write below exactly what we found in part A. So we found that log of n base 10 is equal to 3.08 plus 0.154 t. And by comparing, we see that the 3.08 is the log of a base 10, and the 0.154 is the log of b base 10. Hence, we have that log of a base 10 is 3.08, and the log of b base 10 is 0.154, which means that a is 10 to the 3.08, which gives an answer of 1,200 to 3 significant figures, and b is 10 to the 0.154, which gives an answer of 1.43. For part C, we are told that when small t is capital T, the number of subscribers hits 500,000, and we need to find the value of capital T. So in other words, we have the value of small t being capital T, the value of capital N being 500,000. We need to find capital T. So I will actually say log of 500,000 base 10 is 3.08 plus 0.154 capital T. So log of 500,000 base 10 minus the 3.08 divided by 0.154 should be giving me the value of capital T, and this turns out to be 17.0 years. In question 5, we are being given the graph of f of x. It's the modulus of kx minus 9 minus 2. K is a positive constant. It is crucial to realize that k is positive here. And we have an intersection on the y-axis at A. We've got the vertex at B. and we need to find in part A the y coordinate of A and the x coordinate of B. Now in these kind of situations, the first thing we could do is identify each line segment with its equation, which does not involve the modulus sign. So on the right hand side, it's y is kx minus 9 minus 2. So the line is going uphill, k is positive, so this agrees that this is the line segment on the right hand side, and therefore this simplifies to y is kx minus 11, and then on the left hand side, y is minus brackets kx minus 9 minus 2, which is minus kx plus 9 minus 2, and therefore this is minus kx plus 7. So this immediately leads to A having y coordinate 7, because when x is 0, y is 7. So let me write that down. So at A, y is 7, and then to find in terms of k the x coordinate of B, well, we said that the B is the vertex, it's the point where the modulus vanishes. So at B we have that kx minus 9 must be 0, and therefore we have that x is 9 over k. This is the x coordinate of point B. Now in B we need to find in terms of k the range of values of x that satisfy the inequality that the modulus of kx minus 9 minus 2 is less than 0. In other words, we need this part here, so we want to be between this point here and this point here. So we should be identifying the x coordinates of the cuts on the x-axis. For this point here, we've got that kx minus 11 is 0, which leads to kx is 11, and therefore x is 11 over k. And for this point here, we've got that minus kx plus 7 is 0, so 7 is kx, and therefore 7 over k is equal to x. So we need to be between 7 over k and 11 over k. So our answer to part B should be all x such that 7 over k less than x less than 11 over k. Please note that even though I gave my answer in set notation, the mark scheme does not require set notation to award full marks. In C, we have a line y is 3 minus 2x intersecting the f of x at two distinct points, and we need to find the range of possible values of k. So I could start by drawing the line. This is the line y is 3 minus 2x. Notice that the line is fixed. The gradient and the y-intercept are fixed. However, for f of x, we know that k varies. K is a positive constant. We are certain that the vertex here, B, will surely be on the positive x-axis. We have already found that its x coordinate will be 9 over k. And when kx minus 9 is 0, the y value is negative 2. So its y value will be negative 2. So for two distinct cuts with the line y is 3 minus 2x, it is clear that the vertex should go below the straight line. We could also see an animated solution here just to see what's happening. So we've got k varying between 0 and 5. So at this point we've got no cuts, and then when the vertex hits on the line itself, we've got a single cut, and then when the vertex is below the line, we've got two distinct cuts. So this leads to the conclusion that for two distinct cuts, we need to have the vertex below the line. So we start by writing that B has coordinates 9 over k, negative 2, and we need the vertex to be below the line. So when x is 9 over k, I will substitute this into y. So y is 3 minus 2 times 9 over k, which leads to y being 3 minus 18 over k. And we want the vertex, the negative 2, to be below the y value. So this means that we want 3 minus 18 over k to be greater than negative 2. So we are forcing the vertex, the B, to be below the line. So 3 plus 2 is 5, greater than 18 over k. I can cross multiply without changing the inequality direction because k has been given to be positive. 5k is greater than 18, which leads to k being greater than 18 over 5, and that's the final answer for part C. In question 6, we've got f of x defined here, and we need to show that the derivative f dash of x can be put into this form where k is an integer to be found. So I'll be applying the product rule of differentiation here. F dash of x will be 5, and then I differentiate the first, which is 2x, and I keep the second, 4x plus 9 to the half, plus I keep the first and I differentiate the second. The derivative of 4x plus 9 to the half is get the power down, deduct 1 from the power, so that's to the minus a half, times the derivative of the bracket times 4, and therefore I can now proceed into simplifying things. Now the a half with the 4 leaves me a 2 here, and then I will write this as 5 brackets 2x times 4x plus 9 to the half plus 2 times x squared minus 2 over 4x plus 9 to the half. Now I could express everything over a denominator of 4x plus 9 to the half. At the same time, I notice that 2 is a common factor, so that can come out, leaving me with a 10 here. And I've got x times 4x plus 9 to the half times 4x plus 9 to the half plus x squared minus 2, and all of it over 4x plus 9 to the half. So this leads to 10 brackets x 4x plus 9 plus x squared minus 2 over 4x plus 9 to the half. And I can now expand the numerator. It's giving me 10 brackets 4x squared plus 9x plus x squared minus 2 over 4x plus 9 to the half, which simplifies to 10 brackets 5x squared plus 9x minus 2 over 4x plus 9 to the half, and therefore the value of k is 10. In B, we need to solve f dash of x is 0, and since we've put f dash of x in this form, we can easily see that it's going to be 0 when 5x squared plus 9x minus 2 is 0. This factorizes into 5x minus 1 brackets x plus 2, and therefore we have that 5x minus 1 is 0 or x plus 2 is 0, which leads to x values of a fifth or negative 2. In part C, we need to find the exact coordinates of P, and P is a local maximum. So referring to the diagram provided, we can see that P has a negative x coordinate, and therefore out of the two values we just found, we pick out the negative. So we start by saying that at P, x is negative 2, and therefore f of negative 2 will be 5 times negative 2 squared minus 2 brackets 4 times negative 2 plus 9 raised to the power of a half, which gives an answer of 10, and therefore P has coordinates negative 2, 10. In D, we have that g of x is 2f of x plus 4, but x is now between minus 9 over 4 and 0 inclusive, and we need to find the range of g. So we had the diagram here. We are originally defining f of x for x being greater than or equal to minus 9 over 4, which is obviously the cut on the x-axis here on the left-hand side, and we are now restricting this function to be between the cut on the left and the y-axis, so we're looking at this part here. So there we are restricting ourselves in this interval here. We have already found that the y coordinate of point P is 10, we know that the cut here on the x-axis is at minus 9/4. It makes sense to find the cut on the y-axis, so that means we need to find f of 0, which will be 5 times 0 squared minus 2 brackets 4 times 0 plus 9 raised to the power of a half, and this gives an answer of negative 30. So the cut on the y-axis here is at minus 30, which leads to the conclusion that over this restricted domain, we have that minus 30 less than or equal to f of x less than or equal to 10. And therefore, we now have that 2f of x, multiplying everything by 2, will be between 20 and minus 60. So the next sensible thing to do is say that 2f of x plus 4 is between 24 and minus 56, and which is exactly the expression for g of x. So the range of g of x is between 24 and minus 56 inclusive. In 7a, we need to show that the trigonometric equation given here can be written as 3 cos x squared 2 theta minus 13 cosec 2 theta minus 10 is 0. So let me start by writing out the original equation given. We've got 2 sine of theta brackets 3 cot squared 2 theta minus 7 close brackets is equal to 13 sec theta. We need to end up with something that involves cosec of 2 theta only. Therefore, it makes sense to start off by expressing cot squared theta as cosec squared 2 theta minus 1. And we also have 13 sec theta to be written as 13 over cos theta. And therefore, we can cross multiply the 2 sine theta to come over the right hand side denominator. So we've got 3 brackets cosec squared 2 theta minus 1 close brackets minus 7 is 13 over 2 sine theta cos theta. And of course, I recognize on the right hand side the denominator is simply sine of 2 theta. On the left hand side, we've got 3 cosec squared 2 theta minus 3 minus 7. So this means that we're now looking at 3 cosec squared 2 theta minus 10 is 13 cosec 2 theta. And therefore 3 cosec squared 2 theta minus 13 cosec 2 theta minus 10 is 0 as required. In B, it says hence solve for theta between 0 and pi over 2, the given equation. Here we need to give answers to 3 significant figures. We are obviously in radian mode. So we start by factorizing this into 3 cosec 2 theta plus 2 brackets cosec 2 theta minus 5 is equal to 0, which means that either 3 cosec 2 theta plus 2 is 0, or cosec 2 theta minus 5 is 0, which leads to cosec 2 theta is minus 2 over 3, which leads to sine 2 theta is minus 3 over 2, and the other case that cosec 2 theta is 5, and therefore sine of 2 theta is a fifth. Now we notice that the sine of 2 theta can never be minus 3 over 2. It's rejected, it's not valid, because we know that sine takes values between minus 1 and 1. So this is rejected. For sine 2 theta is a fifth, we start by finding the principal value, which is shift sine of a fifth. This gives an answer of 0.20136, and therefore we have that 2 theta is my PV plus 2 pi k, or 2 theta is pi minus the PV plus 2 pi k. I will divide everything by 2, leading to theta being 0.10068 plus pi k and theta is 1.47012 plus pi k, and therefore we've got solutions for theta of 0.101 and 1.47 correct to three significant figures. In question 8, we're given the velocity as a function of time, and we need to use calculus to find the maximum velocity during the race. So we need to start by saying if the velocity is 12 minus e to the t minus 10 minus 12e to the minus 0.75 t, then we want to find dv dt. So dv dt will be minus e to the t minus 10 minus 12 times minus 0.75 e to the minus 0.75 t, which simplifies to minus e to the t minus 10 plus 9 e to the minus 0.75 t. And for a maximum velocity, we need dv dt to be 0. So we need to solve minus e to the t minus 10 plus 9e to the minus 0.75 t is 0. This leads to 9e to the minus 0.75 t is e to the t minus 10, and therefore we can say that 9 is e to the t minus 10 over e to the minus 0.75 t. Now, because we've got division with a common base, we can deduct the indices, and therefore this leads to 9 is e to the 1.75 t minus 10. So ln of 9 is 1.75 t minus 10. So 10 plus ln 9 over 1.75 is the value of t. We haven't finished. We need to find the velocity at this time. So when t is equal to 10 plus ln 9 over 1.75, I will be substituting this into the expression for v, and we get that v turns out to be 11.9 meters per second. For part B, we are told that the sprinter runs 100 meters in capital T seconds, so that this integral here gives a value of 100, and we need to show that capital T is a solution of this equation here. So we start by writing out the integral. We integrate. 12 gives me 12t minus e to the t minus 10 minus 12e to the minus 0.75t over minus 0.75 from 0 up to t, and this is equal to 100. If I substitute the capital T, I will be getting 12 capital T minus e to the t minus 10 minus 12e to the minus 0.75 capital T over minus 0.75 minus, substituting the lower limit, will be 0 minus e to the minus 10 minus 12e to the 0 over minus 0.75, and this is equal to 100. Now this means that we've got 12 capital T minus e to the t minus 10 plus 16e to the minus 0.75 t plus e to the minus 10 minus 16 is equal to 100, and therefore we have that 12t is equal to 116 minus 16e to the minus 0.75 t plus e to the t minus 10 minus e to the minus 10, and if we divide by 12, we've got that t is 1 over 12 times 116 minus 16 e to the minus 0.75 t plus e to the t minus 10 minus e to the minus 10 as required. Part C, it's an iteration formula, and we need to start with t1 being 10 to find the value of t2, and then find the time taken by the sprinter to run the race. So using the calculator, we start with t1 is 10. We substitute into the iterative formula given. We get that t2 is 9.7493. And if we continue the iterations, we see that the first, the second, the third decimal place stabilize, and eventually we get that t is 9.7293 seconds, Do remember to include the units because we are asked to find the time, so I have to say 9.7293 seconds to get the marks. In question 9, we've got the curve with the equation of y is 1 plus 2 cos x over 1 plus sine x, and we need to start off by showing that the x coordinate of the minimum point, the m, satisfies 2 sine x plus cos x is negative 2. So we will be using the quotient rule here. Dy dx is equal to the derivative of the top, which is minus 2 sine x, and we keep the bottom, minus keep the top, and we differentiate the bottom to give us cos x, and all of it over 1 plus sine x squared. We will be expanding the numerator to get minus 2 sine x minus 2 sine squared x minus cos x minus 2 cos squared x, and all of it over 1 plus sine x all squared. Now this can be written as minus 2 sine x minus cos x minus 2 brackets sine squared x plus cos squared x, and all of it over 1 plus sine x squared. Now we know that sine squared x plus cos squared x is equal to 1, and therefore we get this to be minus 2 sine x minus cos x minus 2, and all of it over 1 plus sine x squared. Now we know that at m we've got dy dx being 0, as this is a turning point, and therefore we want the numerator to be 0, so we want minus 2 sine x minus cos x minus 2 to be 0, which leads to minus 2 is 2 sine x plus cos x as required. In part B, we need to find the x-coordinate of m, giving our answer to 3 significant figures. I will actually start by expressing 2 sine x plus cos x in the form of r sine of x plus alpha for r and alpha to be found. I expand the right-hand side using the addition formula for sine. It gives me r sine x cos alpha plus r cos x sine alpha. I will be equating the sine x terms, and then I will be independently equating the cos x terms. So this leads to 2 is r cos alpha and 1 is r sine alpha. So we have that 2 over r is cos of alpha and 1 over r is sine of alpha. I will draw a triangle here, and the alpha is here. It's a right angle triangle, so 2 over r for the cos, 1 over r for the sine, and we get through Pythagoras that r is 2 squared plus 1 squared square root, which is of course root 5, and also tan of alpha is 1 over 2, which means that alpha turns out to be 0.46365. We are in radian mode. So we conclude that 2 sine x plus cos x is root 5 sine of x plus 0.46365, and this is equal to negative 2. So if I divide by root 5, I get sine of x plus 0.46365 is negative 2 over root 5, and therefore my principal value here will be shift sine of minus 2 over root 5, which works out to be minus 1.1071, and hence we have that x plus 0.46365 is equal to the PV plus 2 pi k, or x plus 0.46365 is pi minus the PV plus 2 pi k. This leads to the left-hand side, giving me x is minus pi over 2 plus 2 pi k, and the right hand side that x is 3.785 plus 2 pi k. Now remember that x is between minus pi over 2 and pi over 2, so the solutions that this equation yields are minus pi over 2 and 3 pi over 2. They are the endpoints of the interval which are not included, so I say that I have to reject this since x is between minus pi over 2 and 3 pi over 2 with the inequalities being strict. And on the right hand side we get the solution we were after. We get that x is 3.79.